for example 2, we have if sine of theta is equal to negative square root 3 over 2. So again, the format of these is they're going to give you a standard trig function with a standard angle theta. So if sine of theta is equal to negative square root of 3 over 2, and what's different about this problem is they actually give you a range of angles. So they say that the angle is from pi to 3 pi over 2. Now, if you like to think in terms of degrees, that would be from 180 degrees to 270 degrees. So we're talking about in the third quadrant somewhere. So I went ahead and drew that for you. So if sine of theta is equal to negative square root of 3 over 2 in this particular quadrant, now why would they do that? Because we know that this could also be true. Sine of theta could be negative square root of 3 over 2 in the fourth quadrant if you know your unit circle very well. So we're going to stipulate it's going to be in this quadrant. So lastly, what is it asking? It says, what is tangent of theta over 2? So again, it's giving you a standard trig ratio with a single angle, a regular angle theta, and it's asking for a half or double angle. In many cases, it's going to change the trig function to something else. We started with a sine, now we're going to ask what's tangent of theta over 2. So let's go ahead and follow those steps that we followed in example 1. Remember, you're going to write out the identity. So how do you know which identity to use? Well, in this particular case, it's asking for tangent of theta over 2. Now, if we go back, there are two different formulas for tangent of theta over 2. They're basically the same because, they both involve sine and cosine. So many times, for this one, for example, it's not going to really matter because you're going to figure it out either way. I kind of like the one on the bottom better because the sign is on top, the bottom has a plus, but that's just me. Maybe when I did it, I used another one. It doesn't really matter. The one that might come into play if you had to decide for the cosine of 2 theta is basically if you're already given cosine, you might as well just use the top one, right? That way you don't have to figure out sine and vice versa. So in that one, it's kind of clear as to which one to use. Okay, so going back, we're going to use that bottom one like I said. So we're going to write that one out, sine of theta on top, cosine of theta plus 1 on the bottom. So keep in mind, we were only given sine of theta, right? And so we already know the top part of the formula to plug in. We do not know the bottom. We don't know what cosine of theta is. So that leads us to step 2. Solve for an unknown trig function. So in this case, we need to solve for cosine of theta. Let's read this together. It says we will do this by using what is given to us, drawing a triangle and solving for the third side. As I've said before, always draw a triangle when trying to figure out the other trig ratio. That way, just the visual really helps me, and I think it'll help you as well. So again, we were given that we are going to be in this particular quadrant on the unit circle, namely the third quadrant. So I'm actually just took a snippet of this app that I've made for the unit circle, and I can see that when my angle is down here, if I draw sine down in this third quadrant, what is cosine, right? And this is important, right? Going back to what I drew here, if we were in the fourth quadrant, cosine would be positive, right? However, we're in the third, based off this information they gave us. So we know that cosine is actually, or this side length rather, is going to be negative. So it says we get the triangle on the right, and since sine is opposite of our hypotenuse, I'm going to label my opposite side negative square root of 3 and my hypotenuse 2. I could label this negative square root of 3 over 2 and the hypotenuse 1 using the unit circle, but you're going to get the same thing, and to me this is a little bit easier to deal with, especially when using the Pythagorean theorem. So anyway, if you don't want to do that, you could just look at the unit circle and know that if sine is negative square root of 3 over 2, then cosine is going to be negative 1/2 in this quadrant. However, if you don't know that, you can use the Pythagorean theorem. A squared plus b squared equals c squared, and we're solving for a right here. So this plus this squared equals 2 squared. You're going to get a squared is equal to 1. So you're going to get a is equal to plus or minus 1, basically. We know we're in the third quadrant, so we know the adjacent side a is going to be negative 1. And again, if you look at that, you can see it's to the left of the origin. We don't really see that unless we see the... Here's the axis that I drew, and you can see in the third quadrant a is going to be negative. Okay, so now that we have that established, we can now determine what cosine is. So cosine is adjacent of a hypotenuse, so we now know adjacent over hypotenuse would be negative 1/2. And again, if you knew the unit circle, you would know that. And in fact, the angle that we're actually at, if you know the unit circle well, would be 240. But you don't need to know that. As I've said before with this lesson, this is not asking for what theta is. And I'm repeating that because my students in the past have insisted on that. But it's in fact not. If you read the question, it's just asking for what is tangent of theta over 2. And remember, that's just a ratio we're going to get back, or some number, right? It's not an angle. It's a ratio of two side lengths, given basically asking for tangent of half of the angle given. So if the original angle was, well, actually we already know the original angle based on the unit circle. We know the original angle is 300, so the new angle is going to be 150. But even if we didn't know the original angle, we could still figure it out using these formulas, which is the whole purpose of this lesson. Okay, so now we can fill in the rest of the double angle formula, now that we know that cosine is negative 1/2. So for step 3, we're going to plug in what we figured out. One fact, we were given that sine of theta was negative square root of 3 over 2. We're now going to come and plug in cosine of theta, which is negative 1/2. And that way we can solve for tangent of theta over 2, just simply simplifying this complex fraction. So we have negative square root of 3 over 2 on top and negative 1/2 plus 1 on the bottom. The bottom actually going to simplify to 1/2, so it's not going to be too bad. Step 4 is to solve. So we get 1/2 on the bottom. We have negative square root of 3 over 2 on top. We're going to do keep, change, flip. Keep the top, change division to multiplication, and flip the bottom. And we can see that the 2's are going to cancel. And now we have a negative square root of 3 over 1, which we know is equal to negative square root of 3 over, negative square root of 3. So our final answer, tangent of theta over 2, is equal to negative square root of 3. Given the fact we were given that sine was negative square root of 3 over 2. Now, because I know this is on the U circle and I know the original angle was 240, let's think about that. What is half of 240? I'm going to actually draw this to really help you guys solidify this concept. Let's go ahead and draw this. Okay, so we started out, and this is only because I know the unit circle well and I know what angle was started at. Okay, so we started at 240, right? We started at 240 degrees, and we knew that at that point the y value is negative square root of 3 over 2, or the sine value, right? So what's half of 240? Well, half of 240 is 120, right? 120 degrees. And based on the information, we know that tangent is negative square root of 3 right here. So we can check our work that way. But again, the point of this lesson is you might not always know what that angle is, but without knowing the angle per se, you can still plug it into the formula and figure out what the ratio is if you were to cut that angle in half or double it. So that's it for this particular example. If you have any other questions about it, let me know.